Hello everyone and welcome back to Fractal Frontier Maths. If you are preparing for the CSIR NET exam, this PYQ series, previous year question series on ordinary differential equation is going to be highly valuable for you. In our previous videos, we explored important concepts like Picard's existence and uniqueness theorems, Peano's existence theorem, and tackled several specific initial value problems. In today's video, we are taking it a step further to discuss the concept of the maximum interval of existence using Picard's successive approximation theorem. We will analyze previous year questions to understand how to determine the largest interval on which a solution to a given differential equation with initial condition exists by applying Picard's approach. Let's get started and don't forget to like, share, comment and subscribe for more mathematics content focused on CSIR NET or university preparation. So first we will briefly explore about the interval of existence, means how to calculate the interval of existence for a given initial value problem. So we consider the initial value problem dy by dx equal to f of xy subject to the condition yx0 equal to y0. It is a given initial value problem where we assume that fxy is continuous in a closed domain D, where domain D is defined as all the points in domain R square such that x minus x0 less than equal to a and y minus y0 less than equal to b. It is a closed domain where function f of xy is continuous. It is assumed that a and b both are positive. Since f is continuous in a closed domain, so it will be bounded on the domain D. So we assume that the mod of fxy is less than equal to m. So m is the bound of the function fxy for the domain D. Now we define h equal to minimum of a b by m. Then the maximum interval of existence is given by mod x minus x naught less than equal to h. So what is the information? Why we need this information? So if a differential equation is given of the type dy by dx equal to f of xy and a condition is given yx0 equal to y0, then how to find the maximal interval of existence? So first we have to define the domain D. Sometimes the domain is given in the problem. Then we have to find the maximum bound f of xy mod less than m. So we have to find the value of m, then we will define h such that it is minimum of both the a and b by m. When we find the value of h, we can easily determine the maximal interval of existence such that x minus x0 less than equal to h. So let's discuss the problem asked in CSIR NET June 2011. The problem is, for the initial value problem dy by dx equal to y square plus cos square x, where x is greater than 0 and y0 equal to 0. The largest interval of existence of the solution predicted by Picard's theorem is. So we have to find the largest interval of existence for the initial value problem. These are the options. So first we will find the bound m and then we will calculate the value of h. So the given initial value problem is this, subject to the condition y0 equal to 0. Here when we compare it with dy by dx equal to f of xy, this is our f of xy. So f of xy equal to y square plus cos square x, and here domain is not given, so we will assume here x0 value is 0 and y0 value is 0. So the domain we can define as D equal to xy belongs to R square such that x minus x0 is 0 less than equal to a and y minus 0 less than equal to b. So fxy is continuous on the closed interval because it composed by two functions. One is polynomial function and one is trigonometric function which is continuous. Now we will calculate the value of mod fxy. So it will be mod y square plus cos square x. By using triangular inequality, we can write it as less than equal to mod y square. It will be less than equal to mod y square plus mod cos square x, and we can write it as mod y square plus mod cos square x. Since cos x lies between -1 to 1, so cos square x is less than equal to 1. So we can write it as this will be 1, and in the domain y is less than equal to b, so we can replace its upper bound b. So mod f of xy is less than equal to b square plus 1. So we will take this as the value of m. Now we define h equal to minimum a b by m. By placing the value of m, we will get minimum a b divided by a square plus b square plus 1. So how to find the minimum value? So we will use the concept of maxima and minima from differential calculus. So we assume this as a function of b. Okay. For the minimal value of fb, we have the necessary condition as the first derivative with respect to b must be 0. So we will calculate the first derivative. So it will be the first derivative of fb, and its value will be 1 minus b square divided by b square plus 1 ka whole square equal to 0. Since b is a real number, so b square plus 1 will not be 0. So we can write it as 1 minus b square equal to 0. So we will get b square equal to 1 or b equal to plus minus 1. Since it is assumed that b is greater than 0, so b will be 1. So we have find the value of b such that fb is minimum. Obviously we have to check the condition for minima, which is the second order derivative. F double dash b must be greater than 0. We can check it and it will be greater than 0. So the value of h will be minimum a. We replace the value of b as 1, so it will be 1 upon 1 square plus 1, that is 1 by 2. Okay. So since a is not given, we can choose the value of h as 1 by 2. So the maximum interval of existence will be mod x minus x0, where x0 value is 0. So mod x minus 0 less than equal to h, and by substituting the value of h as 1 by 2, we will get mod x is less than equal to 1 by 2. So x will be in 0 to 1 by 2 because x is already given as greater than 0. So the maximum existence interval will be closed interval 0 to 1 by 2. So option B will be the correct option. So this will be the correct option. To understand the concept more clearly, we will take another example. The problem is largest interval around 0, 0 of initial value problem y dash x equal to x square plus y square subject to y0 equal to 0, where r is given by mod x less than equal to 1 and mod y less than equal to 1 by using Picard's existence and uniqueness theorem, in which solution exists uniquely. So we have to find the largest interval around the origin 0, 0 such that the initial value problem has a unique solution on the region R. So we have to use Picard's theorem to find the largest interval of existence. The initial value problem is y dash x equal to x square plus y square subject to y0 equal to 0. Here, if we compare it with dy by dx equal to f of xy, we will get f of xy equal to x square plus y square. And the given domain is mod x less than equal to 1 and mod y less than equal to 1. So here a and b both are 1. Since fxy is a polynomial function in x and y, so it is continuous on the domain R. Now we have to find the bound of function fxy. So mod fxy equal to mod x square plus y square. By using triangle inequality, we can write it as less than equal to mod x square plus mod y square. Since we have mod x less than equal to 1 and mod y less than equal to 1, so we can substitute the higher bound 1 plus 1. So mod fxy will be less than equal to 2. So we can take m as 2. Now we define h equal to minimum of a comma b by m. Here a and b are 1 and m is 2, so we can write is 1 comma 1 by 2. So its minimum value is 1 by 2. Therefore the maximum interval of existence is mod x less than 1 by 2. So the option B is correct option. Now let's discuss some other problem. This is problem asked in CSIR NET June 2013. So the problem is, consider the initial value problem dy by dx equal to y square subject to the initial condition y0 equal to 1 where xy belongs to R cross R. Then there exists a unique solution of the initial value problem on. So we have to find the interval. But there is one problem. In Picard's theorem, we have assumed that the xy belongs to a bounded closed domain D. Okay, but here xy belongs to the whole Euclidean plane R square. So the domain is not closed, not bounded. So we cannot apply the Picard's theorem. To find the interval here, we will first solve the differential equation with the initial condition, then analyze the option. So let's start. The given differential equation is dy by dx equal to y square, which is a first order differential equation, and it is separable in x and y. So we will separate the variables. So dy by y square equal to dx. By integrating, it will be integration 1 upon y square dy equal to integration dx. So the integral of 1 upon y square is minus 1 upon y, and integral of x is x, and c is the constant of integration which needs to be determined. The given condition is y0 equal to 1, that is at x equal to 0 y is 1. If we put here y equal to 1 and x equal to 0, we will get c equal to minus 1. So a solution to the given initial value problem is minus 1 upon y equal to x, and by taking c equal to minus 1, so we will get y equal to 1 minus x. This solution blows up when x not equal to x equal to 1. So for the existence of solution, we must have that x is not equal to 1. Now we analyze the option. The first option is minus infinity to infinity. Since 1 belongs to that interval, so this option is not correct. Option C is minus 2 to 2. Since 1 belongs to that interval, so this will also be incorrect. Similarly, option D is incorrect. Now in option B, the interval is given as 1 to infinity. Since 1 does not belongs to that interval, so it is open from n. 1 is not member of this open interval. Therefore option B is the correct option. Similarly, we can find interval for other problems when the interval is not bounded. The domain D is not bounded. So in that case, we will find the solution of the differential equation, use that given initial conditions, and then analyze the solution yx. And based on the solution, we will decide which option is correct or which are not. In next video, we will talk about some more problems from existence and uniqueness. asked in CSIR NET Mathematical Science. Till then, keep learning, keep exploring. Thank you for watching.